Hey, what's up guys? It's your boy Mike here. So today we are going to look into a 3D visualization of a screw that will be degraded in a solution of chemicals. It's a 3D data set with, and then I'm looking at the 3D data set using a 3D visualization called ParaView. The degradation of a screw is essentially just a screw inside a solution, and over time you'll see that the screw gets degraded by fluorine and chlorine, and the screw made out of magnesium, you'll see that magnesium in the screw uh, will be like diffused out. So let's just go into it. First, this is what the data set looks like. If I increase the opacity to like 1, you'll see that it's basically just a cylinder. So in order to actually see inside the screw, or inside the actual cylinder to see inside the screw, you actually have to like turn the opacity down to see the screw. Um, and right now, you can actually see the screw inside the cylinder. It's like the one that's like dark blue. And the reason why the screw is like in the cylinder is because when they were like creating this data set, I believe um, they they had like a cylinder, and they put the screw inside the cylinder, and then like the solution was also recorded alongside with the screw. And so if we want to see like just the screw, we need to do some clipping. But before that, I can just show you that this data set is like as a temporal as time, as it's like, so you can see the screw like degrading over time. So this is fluorine. Let me stop this and just show you magnesium. And we'll just continue on. So you can actually see the magnesium being diffused to the solution. This is using a heat map color scale, with blue being like not a lot of magnesium, white being a little bit of magnesium, and red being a lot of magnesium. So you can see that the solution gets like more and more lighter in blue, meaning that it gets more magnesium. I should probably change the color scale because it's using 2 color palettes. But anyways, and then I believe the max is like 46. So once it gets like 46, you'll see like it gets more and more diffuse. But there's better ways to do this visualization. For example, we can like cut the solution in half, so that we can actually see inside the solution alongside with the screw. Let me turn off the plane. So this is what it looks like cut in half. So you can see it's like cut in half with this clip. And at time 0, there's like no magnesium. All of the magnesium is like inside the screw. And then over time, you'll see that the magnesium kind of goes out into the solution from the screw inside into the solution. There's no way to speed this up, but I'll just skip to the end. And please skip to the end. Okay, and then when I skip to the end, you'll see like the magnesium has like diffused out. So with the clip, we can cut 3D objects in half to see inside of it, which is pretty cool. Contours are not that useful, but it is there. It allows you to kind of see the surfaces of the points, basically. I think it might be useful in other data visualizations, but it does kind of help. You can see like it's still sort of useful. But then there's another clip. So if we use clip type scalar, we can actually see inside the solution and only show the screw. So this is just the screw by itself. And this is a clip of the object. So this is just half of a screw. So if this is chlorine. So if I go all the way to back, okay, so you can see that the screw has a little bit of chlorine, but then if I play this out, the screw then gets like covered in chlorine. Yeah. It's a bit finicky because like I'm not sure if they messed up on the data set or not. And then this is the ISO volume, which okay, the ISO volume looks a bit better. It looks like it makes more sense. You can actually see as it goes up, the fluorine kind of penetrates the screw, but not all the way. Because I believe how they did it is that they measured it, and they measured it by distance, and so there's no fluorine inside the screw, but you can see it kind of covers the screw. Oh, another thing is that you can actually see the screw get smaller as so this is times 0. If you go all the way here, the screw actually like degrades and it loses some mass. You can look at the contour. Contour I don't think is that useful, but it is a visualization. If I go all the way to the beginning, you'll see that there's very little magnesium inside the solution, but as it goes out, the magnesium goes inside the solution and the screw loses some of the solution. Let me see if there's other ones that are interesting that I have. This is half of a screw. Again, the fluorine doesn't really go inside. The fluorine can't really penetrate, it just goes in the surrounding area of the screw. The magnesium, yeah, get a minute. Okay, this actually is wrong. No, I was just selecting the wrong. Okay, there we go. Okay, the magnesium actually exists inside the screw on the surface and then on the inside. That makes sense. This also makes sense. Sometimes on some of the surface of the screw won't be purely magnesium, but the inside will be purely magnesium. The fluorine, this kind of makes sense. The fluorine shouldn't really be inside the screw. The screw should be mostly fluorine. But if I go but then as the screw degrades, it gets more and more fluorine. Then we can look at chlorine. This doesn't. I don't know if this makes sense. I don't think the chlorine. I don't think the screw is made out of chlorine at time 49. Time 49. So like I think there's like some problems with the data set. I don't think chlorine would. I'll have to look more into it, but I think there's just problems with this data set. But whatever. Okay, let's look at this. Okay, but then if you look inside the screw, yeah. Okay. Let's look at the ISO volume again. Okay, so this is the ISO volume. If I look at chlorine, okay, at time 0, it makes sense for like the chlorine to not be inside the screw, but then at time 49, it looks like the entire screw is completely slobbered with chlorine. This makes sense. Fluorine makes sense. Like the inside of the screw probably isn't made out of fluorine, but with chlorine, it looks like the entire screw is made out of chlorine. And then with magnesium, okay, it makes sense for the entire screw to be made out of magnesium. That makes sense. Because magnesium is a metal. Okay, but then, yeah, okay, this also makes sense. The outside of the screw has some other solution, so it's like not fully magnesium. Okay, that also makes sense. But then I don't understand why chlorine is the screw is just made out of chlorine now. It has a lot of chlorine. So I don't know if that's like a thing. So, but I'm gonna assume that everything looks fine for the dataset, and yeah, for this dataset, I would say the most important visualization um is the clipping, because clipping actually allows you to see inside the solution. If you don't have clipping, it's actually just a cylinder, and with clipping you can actually see like what's inside the solution. Let's look at chlorine. Yeah, I don't know what they did, but chlorine is like just the entire thing is just chlorine. So I don't know what's happening with chlorine. Alright. Well, that's pretty much it. Bye.